Okay, this is McGraw-Hill Chapter 6, Section 7, last section in the chapter. This deals with imaginary numbers, complex numbers. First of all, imaginary numbers. Before, we were taught that you couldn't have a negative inside a square root sign or any even root. Well, now you can, because now what we do is we take that negative out and it becomes an I. And that leaves you a positive in the square root sign, so now the square root of 64 is 8, so it's plus or minus 8i. Same thing here, you reduce this the same way, bring the I out first, then simplify your 50, 25 times 2, find the largest perfect square that divides into it. Square root of 25 is 5, comes out and multiplies times the I, so you get plus or minus 5i square root of 2. And remember, anything that comes out of a radical sign multiplies times anything outside the radical sign. In this one here we have a negative, square root of negative 4, so the first thing we do is bring the I out. Square root of 4 is 2, so it still becomes plus or minus 2i. If you were looking for the principal one, this would be negative 2i only. This one here, there's no perfect square that goes to the 29, so we just bring the I out and it becomes I square root of 29. In example 2, page 557, we have fractional imaginary numbers. So in terms of here, we have square root of negative 100 over square root of negative 25. We write it as one radical, square root of negative 100 over negative 25. Negative divided by a negative becomes a positive. 100 divided by 25 becomes 4. Square root of 4 is 2. Make sure you understand that you can go either way with your radicals. You can keep it this way if you can simplify the top by itself and the bottom by itself. But if you can ever divide the bottom into the top and simplify it, you should always write it as one radical. Square root of negative 25 times square root of negative 9 becomes I squared root of 25 times I squared root of 9, which I squared root of 25 becomes 5i. I squared root of 9 becomes 3i. 3 times 5 is 15. I times I is I squared. I squared is negative 1, so it becomes negative 15. Make sure you understand the powers of I. On the powers of I the first power is I the second power is negative 1, I the third power is negative I to the fourth power is 1, and then it repeats itself. So I to the fifth would be I to the sixth would be negative 1, I to the seventh, negative I to the eighth, 1, and then it repeats itself again. So all you have to do is really divide by 4, and whatever remainder you have, if you have a remainder of 1, it's here, remainder of 2, remainder of 3, remainder of 4. Okay? Or remainder of 0, I'm sorry. We come down here to letter C. We have negative 5, square root of negative 5i times square root of negative 5i, which becomes I squared of 5, times I squared of 5, which becomes I squared root of 25. I squared again is negative 1. Square root of 25 is 5, so we get negative 5. Again, looking at this, make sure you understand it just repeats itself by 4. So what you want to do, like here with I to the 13, divide 13 by 4, you get a remainder of 1. Remainder of 1 makes it 1. Here, I to the 18th, you divide by 4. 4 times 4 is 16, you get a remainder of 2. Remainder of 2 makes it negative 1. Here, you divide by 4 again. That's going to give you 26. You get a remainder of 3. Remainder of 3 makes it negative I. Here, you got I to the 32nd. Divide by 4, you get no remainder. A 0 remainder means it's 1. We come over here. Here's multiplication of these. Oh, and first of all, let me say this. Over here we had strictly imaginary numbers which dealt with I. When we combine an imaginary number with a real number, the real number is always written first, the imaginary second, and this is called a complex number. When we add or subtract complex numbers, we can only add real to real and complex to complex. So if I have 1 minus 5i plus negative 3 plus 7i, 1 minus 3 is negative 2. Negative 5i plus 7i is plus 2i. So it becomes negative 2 plus 2i. And this is in correct complex number form. Real number first, imaginary second. On this one, I have negative 1/4 plus 3/5 I minus 1/2 minus 1/10 I. So the first thing I got to do is I got to change this 5 to a 10. So when I add them, so multiply the bottom by 2, the top by 2, I get 6/10. I got to change this 1/2 to 4, so multiply the bottom by 2, top by 2, I get 2/4. Now I can add negative 1/4, negative 2/4, negative 3/4. 6/10 plus 1/10 is 7/10 I. And now we're in correct form. And this one here, we're just going to do the same thing that we did in the beginning problems. Bring the I out, simplify 8, 4 times 2, square root of 4 is 2, so it becomes 2i square root of 2. Do the same thing with square root of 18. Bring the I out, 18 breaks down to 9 times 2, square root of 9 is 3, so this is 3i square root of 2. Now we can add them. 2i plus 3i is 5i square root of 2. Remember, when you add or subtract radicals, not only do they have to be the same radical, square root to square root, cube root to cube root, but they have to be the same irreducible value inside. Come to example 6, this is multiplication of radicals. Just do the same thing that we do with all binomials. 10 times 2 is 20. 10 times 3i is 30i. Negative 5i times 2 is negative 10i. Negative 5i times 3i is negative 15i squared. I squared is negative 1 times negative 15 is positive 15, plus 20 is 35. 30i minus 10i, 20i. Done. Here we're simplifying, and if you remember with radicals, we simplify by the conjugate. We're going to do the same thing here, except it's called the complex conjugate, because it's a complex number. So here we have 4 minus 3i over 4 plus 2i. So same first term, opposite sign, same last term. Only thing we got to do is multiply by both. So this becomes 4 times 5, which is 20. 4 times negative 2i, which is negative 8i. Negative 3i times 5, which is negative 15i. Negative 3i times negative 2i, which is positive 6i squared. 5 times 5 is 25. Plus minus is a minus. Well, positive times a minus is a minus. 2i times 2i is 4i squared. Combining the top, I squared becomes negative 1, which makes this a minus 6, so 20 minus 6 is 14. Negative ai, negative 15i is negative 23i. This becomes 25 plus 4, which is 29. Now all we do is move this 29 under each one. 14 over 29 minus 23 over 29i makes it in correct complex number form.